Last night our homework was practice question set number 7 that I want to go over here right now. The first question deals with all this information about a Van de Graaff generator, including the mass of a metal sphere that's looks like it's being repelled by the Van de Graaff generator, an angle, and some forces of a vector diagram, and so on. Lots of stuff, right? Lots of stuff. You should read through this stuff. Generally, when we get a lot of information like this, the strategy that I would suggest would be skim through it. Okay? Skim through the information first time. Okay, and if you happen to notice anything happens to jump out at you, just make a little note of it, circle it, or underline it, or highlight it, or make a little note. But don't read it in detail. Just skim through it. And then once you read the question or questions that are relevant to it, then go back and read it in a little bit more detail if you have to. Okay? Skim through it always, and then read it in more detail if you have to later on. All right, let's pretend we skim through this, and then let's look at the question that goes with it. When it touches the generator, the metal sphere becomes what? As a result of the transfer of what? Well, what does the metal sphere become? It says the metal sphere was neutral, and the dome of the Van de Graaff generator was positive. So if the neutral metal sphere touches the positive Van de Graaff generator, and we got to be careful with this because Van de Graaff generators are typically negatively charged. So by default, if we don't read carefully enough, we're probably going to make it negative, right? But if it's neutral touches positive, what's the neutral thing going to become? Positive, right? They're going to want to try to balance out, right? Is this small neutral metal sphere going to balance with the Van de Graaff generator? Probably not. The Van de Graaff is going to hold more charge than the small neutral metal sphere, but they're still going to both become like charges, both become positively charged. All right, so if it becomes positively charged, how does it become positively charged? Has it gained protons? No. Julia? No, so what is it? Yeah, it's lost electrons. It becomes positively charged because it's lost electrons. So the answer for that one would be C. Use the following information to answer the next question. 3 identical conducting spheres, 1, 2, and 3, have initial charges of 4, -2, and -4 microcoulombs. I'm going to draw attention to those negatives and draw attention to the microcoulombs. And then we have some touching going on here. Brief contact with each other. What do they become? 1 touches 2, 2 touches 3, 1 touches 3. Well, let's draw a little table that we do in class one day. We have 3 charges, 1, 2, and 3. They start off as 4 microcoulombs, -2 microcoulombs, and -4. It says 1 touches 2. 1 and 2 touch each other. Well, let's assume that they're going to balance out, right? Because it's the only way that we can handle a question like this is if they actually do balance out. 4 plus -2 is -2. Divided by 2 is -1. So they're going to balance out to be -1 and -1. Right? 4 and -2 is -2. -1 and -1 is -2. Number 3 hasn't changed though, right? Okay, it's still -4 because nothing's touched it yet. Yep. Sorry, say it again? Oh, sorry, it's +2, you're right, yeah. 4 and -2 is +2, which means they're going to balance out to be +1 and +1. Thank you. The third one doesn't change, though, because it hasn't been touched yet. Now, 2 touches 3. 1 and -4. 1 and -4 is -3. Well, -3 divided by 2 is -1.5. So they're going to balance out to be -1.5 and -1.5 microcoulombs. This one stays 1 because it wasn't touched on that one. And then it says 1 touches 3. 1 and -1.5. 1 and -1.5 is -0.5. Divide by 2 gives me -0.25 and -0.25. The second one remains -1.5. All right, there's the final charges on all 3 of them. We want to find the final charge on sphere 1. We see that it's -0.25 microcoulombs, so the answer for that one would be C. Guys, pay really close attention, right? Okay, make the mistake that I made if you're not paying attention close enough, right? Thankfully, Martin was there to correct me on it. But if I'm if I'm just reading through this quickly and trying to rush through it, I might make that mistake, right? The good news is, we've talked about this before, you have almost unlimited time now to write this exam, right? Up to 6 hours to write this exam. And you don't want to take 6 hours to write this exam, because that's ridiculous to take 6 hours to write this exam. In most cases, at least, that's crazy. Your mind is going to be gone if you take 6 hours to write this exam. But you got time to pay attention and not rush through things, right? You don't have to rush through things thinking, oh, okay, look at my watch, I'm going to run out of time. No, you're not. You're not going to run out of time. With 6 hours, if you run out of time, we got bigger issues, okay? If you run out of time with 6 hours. All right, next question. The number of excess electrons on a ball that has a charge of negative 3.6 times 10 to the minus 17 coulombs is what? We did a question almost exactly like this. How do you find a number of electrons? How do you find the number of oranges? Total mass divided by the mass of one orange, or in this case, it would be the total charge divided by the charge of one electron. Negative 3.6 times 10 to the minus 17 coulombs divided by negative 1.6 times 10 to the minus 19 coulombs, which we can get off our data sheet. We do that math, 3.6 times 10 to the minus 17 divided by 1.6 times 10 to the minus 19, and we get a value of 225. Now, they want that expressed in scientific notation, so we'd say 2.25 times 10 to the 2, and then they want the values of A, B, C, and D. A, B, C, and D. So we'd say A, B, C, and D, 2, 2, 5, 2. Does that make sense? Now, sometimes they say, they don't very often do this anymore. This used to be a lot more common. But sometimes they'll say they want the value of B, B times 10 to the W. If we wanted to express B times 10 to the W, what would the answer be? 2? No, B is a base, right? B can be 1 digit or 4 digits or 3 or whatever. The base of this would be 2.25. So B times 10 to the W, 2.25, A, B, C, D, 2252. Okay, in this case, of course, the answer is 2252. Does that make sense? Listen, we want to be familiar with how to express these. Each question on your exam is worth 2%. Each question on the unit test is typically worth 4 to 5%. You don't want to miss 5% on a test because you don't know how to fill something in, right? That would be a shame to miss, to go all the way down to a 95% from the 100 that you're all going to get. Like if you know how to fill things in. You don't want to go down to a 95 because you filled it in wrong, right? Okay, right now, on your last unit test, you filled it in wrong. I marked it right. Okay, and I'll probably do that on your next unit test as well until you get really comfortable with filling things in. But at some point, I'm going to draw the line and say, you're not filling it in right, you don't get the mark for it. Okay, once you have a chance to really get the hang of that. That's it.